Hello there, my dears. I cannot explain how much I miss you. It's terrible. There are only small children here at my home, no teens. Oh, God, I'm really struggling. Yeah, I need you to send a teenager here immediately so I can have conversation and feel like I'm at school. It's the worst. Speaking of, if maybe more than 2 or 3 of you could show up to any of my Zoom meetings so I can see your lovely faces, it would be amazing. Yeah, jerks. Anyways, today we're going to talk about section 8.6. We're going to solve quadratics with a leading coefficient of 1. I'm going to go ahead and warn you, this is my favorite thing to do. It's amazing. You're going to love it. I already know. We're going to skip all these words and move on to example 1. Here, example 1, we've got x squared plus 9x plus 21. Number one thing you need to know to do this, step 1, understand what standard form, oh boy, there we go, standard form of a quadratic. You need to know what that is. It is ax squared plus bx plus c. You can do nothing with these expressions and equations until you have attained standard form. A is the number in front of your squared term. B is always the number in front of the term with an exponent of 1, the term that's just x or just a or just y, okay? And C, think of C as constant. C is the term with no variable at all. First step of these is always going to be, is my expression in standard form? If it's not, you have to fix it so that it is. I'm going to show you 2 ways to do this, but they start out the same way. First, we need to look at our expression and see if it's in standard form. We have x squared plus 9x plus 20. Well, it looks like x squared plus 9x plus 20. Okay? So if we put an imaginary 1 in front of x squared, we can rewrite standard form right below it. And they look like they match. So I'm going to write these down real explicitly. A is 1. B in this case is 9. And C is 20. All of the questions that we're going to do today are all, A is always going to be 1. Okay, that's just for today. So we're going to make a table, and you're going to use this table for factoring all quadratics. On the left side of the table, you're going to write A times C. And on the right side, you're going to write B. You'll only have to write A times C and B here once. From this point forward, you're just going to write whatever A times C and B are. So A times C, we've got 1 times 20. 1 times 20 is 20. For B, we've already got B all by itself here, and that is 9. Okay, so far so good. Now, the left side of the table is what we're going to conquer first. We're going to list all of the numbers, sets of 2 numbers that you can multiply together and get 20. So this is how I like to do it. I like to start with 1 and do 20 divided by 1. What do I have to multiply 1 by to get to 20? I have to multiply it by 20. And then 2. What do I have to multiply 2 by to get to 20? That's 10. I can't take 3 times something and get 20, but I can do 4. 4 times 5 is 20. I can't do 6, 7, 8, or 9, but I can do 10. 10 times 2. So you'll see I've got 10 times 2, but up here above, I've already got 2 times 10. Well, 10 times 2 and 2 times 10 are the same. So I'm going to get rid of 10 times 2 because it's redundant. We don't need it twice. And those 3 pairs are the only things I can write that multiply together to get 20. For column B, I look across the row 1 and 20. I see that, right? I'm going to add those together to get column B. So 20 plus 1 is 21. 10 plus 2 is 12. 4 plus 5 is 9. What I'm looking for are the two numbers I multiply together to get A times C, which are all these, but then I have to find the one that adds up to B, and that's only one option, and it just so happens to be this bottom option, 4 times 5, okay? Here's where our two ideas on how to do this differ. I'm only going to do these differently once. From that point forward, it's up to you to choose which one makes the most sense to you. You'll get the same answer every time, no matter which way you choose. Okay, so this is going to be the factor by grouping method, which is what we did last time. So I'm going to look at this original expression that I had, x squared plus 9x plus 20, and I'm going to keep the first term, x squared. I'm going to leave a whole bunch of space, and I'm going to keep the last term, plus 20. And in the center, I'm going to take these two factors that I got on the A times C column, and I'm going to write them down in the middle with a variable attached. So I took 4 and 5 and made it 4x plus 5x. So if we kind of look back, if I add these together, that gets 9x, which is what I had originally. So I really just wrote the same expression. I split it up very specifically, though, because now we're going to use factoring by grouping. I'm going to group the first two together and the last two together. This is exactly what we did last week. What can I factor out of the first set of parentheses? Well, they have 2 x's here in the first term and 1 x here, so I know I can factor out an x. And the first term doesn't have a coefficient, so I can't really divide it by 4. So x is going to be all I factor out. X squared, I take 1 x away, I'm left with x. I've got 4x, and I take an x away, and I'm left with just 4. So that's x plus 4. Second set of parentheses, 5x plus 20. Well, I only have one term with an x, so I can't factor x out, but I can divide 5 and 20 by 5. So that's going to be what I factor out. And I'm left with 5 divided by 5 is 1, so I'm just left with x. And 20 divided by 5, I'm left with 4. So we got exactly what we wanted. We have x plus 4 in the first parentheses and x plus 4 in the second. So finish our factoring. We have what's inside the parentheses, doubled, x plus 4, and everything outside, x plus 5. And we did it. We factored a quadratic. We totally did it. Option 2. I'm going to call this Boyd's method. It's definitely not my method, but we're going to call it that anyways. Whenever A is 1, which is going to be all of these today, you take your two parentheses that we know we're going to end up with a factor. I look back to my original expression and I find out what the variable is. The variable in this case is x. Well, x is going to go in the front of both of those parentheses. And then I look to my variable, 4 and 5. Those go on the hind end, plus 4, plus 5. Okay, so you can use which either one of those makes the most sense to you from this point forward. I will not be showing you factor by grouping method today again. We will only be doing Boyd's method. Okay, one more thing before we move on. How do we check this? FOIL method is how we check it. X times x is x squared. X times 5 is plus 5x. 4 times x is plus 4x. 4 times 5 is plus 20. Combine like terms, and I get x squared plus 9x plus 20, and that just so happens to be the same original expression we started with. Okay, I know this first problem took like 10 minutes. The rest are going to move lots faster because I'm going to explain lots less, because I totally think you can do it. In fact, I think you can do it so much that I want you to use the exact same method that we just did and factor d squared plus 11d plus 24 all on yo lonesome. Go. I took a drink just to pass the time. All right, here we go. We're going to factor this. Is it in standard form? Question 1, d squared plus 11d plus 24. Let's write below this our ax squared plus bx plus c. Looks like it. You don't ever have to write this underneath here, really, but if it helps you to see if it's in standard form or not, then please do. So put this imaginary 1 there in front of d squared, and I've got a is 1, b is 11, and c is 24. Ugh, this pen hates 4s. Let's make our table. A times c is 24. Oh, that's totally a 4. B is 11. We're going to write the factors of 24. Here's what other thing I'm going to say. If you already know the factors of 24 that add up to 11, there's no need to write them all. If you don't know off the top of your head, please do the work. All right, 1 times 24, 2 times 12, 3 times 8, 4 times 6. Add them up. 25, 14, 11, 10. Looks to me like we have a winner. 3 times 8. We make 2 parentheses. Our variable goes in the front of each, and our factors that we found go on the butt. Let's multiply them together just to double check. We get d squared plus 8d plus 3d plus 24. Combine like terms, and that looks the same to me. Hallelujah. All right, moving on. We're just going to get a little bitty bit crazier. This is the exact same. I'm here to tell you. I've just changed one sign. The process is the same though. Let's first see if we're in standard form. We've got x squared minus 8x plus 12. That is definitely standard form. So I can say that a is 1, b is -8, c is 12. I would definitely write these explicitly down because it will help you so much when we start doing the quadratic formula. All right, let's make a table. Notice I wrote b is -8. That is important. So a times c is 12 and b is -8. I want you somewhere on the back of your notes, on the very top, somewhere where you've got some space, I want you to start a little running tally here. First, if you've got a times c is positive and b is positive, both of your factors are positive. So this is a times c and this is b. Sorry, you can't see that. Then your factors are positive. They all have to be. Now we're looking at if a times c is positive and b is negative. You might be thinking to yourself, how can I add 2 things together or multiply 2 things together that are positive and add 2 things together that are negative? My dears, that just means they both have to be negative. So if a times c is positive and b is negative, both of your factors have to be negative. Okay? If a times c is positive, your factors have to be the same. All right? So let's find 2 negative factors that multiply together to get 12. -1 and -12. -2, -6, -3, -4. And that's all. Now we add. Sorry, my handwriting is just the worst with this pen. -13, -8, and -7. Looks like we've got our winner here with -2 and -6. Just like we did before, we make 2 parentheses. Our variable goes in the front of each, and then our 2 factors go on the back. Okay, we can multiply to double check. I've got x squared minus 6x minus 2x plus 12. That's x squared minus 8x plus 12, which is indeed what we have. All right. Now, your turn to try the next one. I want to bring something to your attention. Is this in standard form? Is this in standard form? Please make the appropriate alterations and factor. Ready, set, go. Gotta erase my giant no now. All right, so I told you, not in standard form. Well, let's make that happen. I'm gonna move it around to m squared minus 22m plus 21. Remember, each term packs with it the sign directly in front of it. All right, let's write our list of A, B, and C. A is 1, B is negative 22, C is 21. Make it a table. A times C is 21, B is negative 22. So I know I'm going to have two negative factors. So negative 1, negative 21, negative 3, negative 7, and that's all I can think of. So we've got negative 22, negative 10. Obviously, this top one's our winner. So we put it in parentheses. Variables go first, factors on the back. Okay, let's multiply and double check. We've got m squared minus 21m minus 1m plus 21. So that's m squared minus 22m plus 21. Looks like it's supposed to. Fantastic. All right, last type of problem. So I want you to see that if we have A times C is negative, it doesn't matter what B is. You have to have opposite signs. Okay? You can't multiply two things together with the same sign and have a positive number. Okay? So let's look what we've got for example 3 here. We've got x squared plus 2x minus 15. Definitely in standard form. So we take A is 1, B is 2, and C is negative 15. Making a table. We've got A times C is negative 15. B is 2. Need to multiply two numbers together to get negative 15. That means one has to be negative. So I've got negative 1 and 15, negative 3 and 5. Now, if these are both the same sign, this is where we would stop, but they're not. So we have to keep going. Negative 5 and 3, negative 15 and 1. Add them up. 14, 2, negative 2, negative 14. Looks like we've found the lucky factors, negative 3 and 5. Whoopsie. Make two parentheses. Variables go in the front. Factors go on the back. Let's multiply and double check. X squared plus 5x minus 3x minus 15. Combine like terms. X squared plus 2x minus 15. Looks like we did it. All right. Do the next one on your own. Is it in standard form? Yes, it is. All right. Here we go. Let's do A is 1, make our list. B is negative 7. C is negative 18. Making a table. A times C is negative 18. B is negative 7. Factors, we've got negative 1 and 18, negative 2 and 9, negative 3 and 6, negative 6 and 3, negative 9 and 2, negative 18 and 1. Add them together. 17, 7, 3, negative 3, negative 7, negative 17, not 9. We care about -7. Looks like it is right yonder. -2 and 9. Like we've all been doing. 2 parentheses, variable in the front, factors on the back. Let's multiply to double check. X squared minus 2x minus 9x plus 18. Put that all together. X squared minus, oh poop. I made a mistake. Do you see what I did? Please say yes, because I just found it by checking my work. Now, isn't that amazing? I wrote -9, -2. It should be -9, +2. So now I get plus 2x and minus 18. So where I have minus 11x, I should have minus 7x minus 18, which looks much more like what we already have. Whew, checking my work is the best. All right, last but not least scenario. We need to be able to solve these expressions, and we're going to use what we learned last week about solving when we factor and what we learned this week about factoring and put it all together. First thing I want to do is make sure this is in standard form, and it's not. So if I want to get standard form to happen, I need to move 27 to the other side. So I'm going to minus 27 from each side. And have x squared plus 6x minus 27 is 0. Just like last week, these only work if you set them equal to 0. So now, this is in standard form. I can write A is 1, B is 6, C is -27. Let's make a table. A times C is -27, B is 6. If A times C is negative, that means our factors have, opposite signs. So I'm going to do -1, 27, -3, and 9, -9 and 3, -27 and 1. Then we add 26, 6, -6, -26. Our winner is the second one here. We factor the way we know how, x in front of each parentheses, -3, +9 on the back. Only thing different now is we're going to have an equals 0. So last week we learned that if 2 factors multiply together to get 0, at least one of them must be 0. So now we take these factors and we set them equal to 0 separately. X minus 3 is 0, x plus 9 is 0. So to solve for x on the left, I add 3. Now I get x is 3. On the right, we subtract 9, and you get x equals -9. So just like last week, x equals 3, comma, -9. If you write x1 equals 3, x2 equals -9, I will know that you've been using my friend photo math. Don't make me hunt you down. All right, I want you to try this last one on your own, and then we'll say sayonara. Okay, not in standard form, so we got to fix it. Subtracting 70, subtract 70. It's z squared minus 3z minus 70 is 0. So we make our table. A times c is -70, b is -3. So we need opposite signs. A times c is negative. So you get -1 times 70, -2 and 35. Not 3, not 4, -5 and 14, -7 and 10, -10 and 7, -14 and 5, -35 and 2, -70 and 1. Whew, that was a lot. We add them up, we get 69, 33, 9, 3, -3, -9, -33, -69. We care about, this one right here. -10 and 7. In parentheses, it goes z and z minus 10 plus 7. Set those equal to 0. Now we set them equal to 0 separately. Add 10 on the left. We get z is 10. Minus 7 on the right. And we get z is negative 7. Again, not the photo math way. 10 comma negative 7. I hope this makes sense. It's real important. You'll use it forever in math. I hope you're amazing and healthy and safe. And I miss you so much. Hugs. Bye-bye.